You should probably wait till the end of the talk to see if it's worthy of applause, but I'll bank that one for later just in case you decide not to. Yeah, so thank you, everybody. Thanks for coming along. It's my second time at Craft Conf. I was here last year, really enjoyed. I love the location. The venue is fantastic. I love being it's quite nice and quite humbling to be surrounded by what I call proper engineering, not what we call software engineering, which I think was quite nice. I've seen quite a few of you out and exploring. You should go out and explore some of the other locomotives, not during my talk, obviously, during somebody else's talk. So I am here to talk about the confusion in the land of the serverless. As Diego mentioned, I did write a book. I've been doing some work in microservices. You might be able to find a copy of the book at the book stand. I worked at ThoughtWorks for many, many years, and then I left to join a startup. I left that startup at the end of last year, a startup called Atomis, when I moved back to the UK. So when I left that startup, I needed to think very carefully about what I did next, and I thought, well, really I need to focus on probably what I think is the single most important thing in IT now, and that is focus on myself. So I set up my own company called Newman and Associates. Just my accountant made me call it that because apparently it sounds a bit more grandiose if you pretend you've got loads of employees. Unfortunately, I don't. Now, I am here today to talk to you about serverless, but the reason I want to talk to you about this in a way is because of, well, we've been having a bit of a momentous year. I think we can all agree that 2017 has so far proved to be a bit of a rocky ride for all of us. And it's been hugely, it's been life-changing, right? And I don't mean about Donald Trump. I mean it's been life-changing for myself because I turned 40 this year, and which is certainly the most momentous moment in my household. I now make loud sounds when I sit down in chairs and make even louder sounds when I have to get up out of those chairs. I think Louis C.K. once said that the single worst moment of his day is when he has to get out of a seat, and I tend to agree with him. And I'm starting to feel a little bit old. I did a training class earlier this week, and I was sort of saying, haven't you read the papers from the 70s, like on scientific papers in like the 70s? Is that a year, or is that a sort of a sitcom or something we're supposed to know about? So I'm starting to feel a little bit like an old fuddy-duddy. I mean, I remember when the internet came on a floppy disk. I got excited when I got a 14.4K modem. It's amazing. You don't see these things anymore, except you see it in an ironic fashion. Hipsters use these sorts of things, but it's jewelry. Whereas this unlocks the power of the internet for me, right? You can go to all those lovely web pages on GeoCities with the little, all the personal web pages that everyone had that same animated GIF of the construction worker, and it said under construction, because we felt the need to tell people that our websites weren't quite finished yet. And we were only on the cusp of discovering the real power of the internet to deliver cat pictures to us wherever we were in the world. I still refer to Facebook as the Facebook because that's its correct name, and that's how it shall always be. I don't understand Snapchat. I see my son sitting there on the sofa every now and then. He takes out his phone, he goes, "Ooh," and takes a photograph, and I say, "What are you doing?" He's Snapchat. And he's taking a picture of himself to send to somebody else that will exist for 10 seconds and then will vanish. And I'm like, well, why? And he'll go, Snapchat. I don't understand that either. Now, I'm not entirely behind the times, right? I'm not some old mainframe programmer. I mean, the fact that my first professional programming language was Fortran 77, which is the year I was born in, by the way, does date me a little bit. But I was a very, very early adopter of Amazon Web Services. More by luck than good judgment. I happened to be around when Amazon Web Services was just starting, and was lucky enough to, with my colleague Chris Reed, to create the world's first ever training course on Amazon many, many years ago. Ended up running the cloud practice and rolling that training out globally and all those sorts of lovely things. So I've been around for a while in the world of sort of automatable infrastructure. So I'm coming into this world of serverless, not completely unaware of the power of the technology, but I'm still very, very much confused. And I'm confused about lots of things. Especially this term, serverless. This is what we're hearing all the time. If I was going to be cynical and wanted my next book to sell, I would write it on serverless. It doesn't actually have to contain any content. I suspect it would just sell with that on front of it. I'm convinced that the shift from the idea coming up to it being overhyped that has been even faster than it was for microservices. Right? Here is microservices surfing the Gartner hype cycle. I think for the serverless tip of the hype curve is going to be even higher. And of course, the crushing trough of disillusionment will be even worse. Because the reason I get confused is because of the fundamental thing of its name, serverless. But there are computers, right? It's just they're still machines, so why do we call it serverless? It's not a helpful phrase, is it? Because especially as a lot of privacy advocates will tell us, there is no cloud. There's just other people's computers. So this is the term doesn't make sense to me. And so I went digging around trying to get back to where the term originally came from. And an old colleague of mine, Mike Roberts, pointed me towards what he thinks is probably the earliest definition of what serverless was, which is from this article from Ken Fromm in about 2012. And he actually has a nice statement for what serverless is. The phrase serverless doesn't mean servers are no longer involved. It simply means that developers no longer have to think much about them. Computing resources get used as services without having to manage around physical capabilities or limits. 2 bits there that are really important. That first bit, there's not computers anymore, but just from the point of view of a developer, you don't actually have to worry about the fact that they're there, and your unit of management isn't defined in terms of other types of computing concepts. It's probably worth noting that this article from Ken is 2012. When I talk to a lot of people about serverless, they say lambda, 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 lambda. This article is in 2012. Lambda launched in 2014. The concept of serverless computing is much, much, much bigger than just, functions as a service. The other thing that it took me a while to get my head around is when I was having this argument, because I am somebody that, for a large part of my career, has sort of straddled that operations and developer divide, never really by good judgment, but mostly just by luck. I like to think of myself as somebody who's a sort of half an ops person. Not the competent half of an ops person, just the kind of conscious, incompetent half of an ops person. But it took me a while to realize when talking to people that the concept of serverless is all about context, right? From the point of view of the person deploying onto a serverless platform, it is serverless. And they get very excited about all this stuff, right? It's so amazing. Oh, it's great, right? You get power pay as you go, and you can write like Node, man. Node's so cool, and it's awesome savings, and yeah, it's amazing. Yeah, great. And then you've got the poor schmucks that actually have to run these serverless platforms. And a lot of the time, these serverless platforms are things inside your own organizations, right? Who just don't understand what on earth is going on. So even the concept of serverless is purely about context, and it's actually mostly in the eye of the beholder. So we need to think of that. It's not just a service platform, it's a service platform for a set of users. I mentioned Mike Roberts earlier. He did a nice article over on Martin Fowler's site talking about serverless architectures. He actually attempts to define a sort of a more concrete definition of what makes a serverless platform. This isn't in the article. I think he's going to add it, but he has 5 sort of categories for a serverless platform. 5 things a platform needs to have to, in Mike's view, be serverless. So Mike talks about this idea of no management of server hosts or server processes. That seems pretty straightforward. It should self-auto-scale and auto-provision based on load. So I don't have to tell it to grow or shrink. It will do that automatically based on usage patterns. That costs are based on precise usage. I part company a little bit with Mike on this one because I think if you deploy a serverless platform inside an organization, you may not necessarily be doing precise cost accounting, but even so for public-based clouds, I think this is, or public-based serverless solutions, I think this is a good point. Performance capabilities are defined in terms other than host size or count. In other words, you don't just say, I want 5 more of these things, or I need X amount more memory, and implicitly, these things should have high availability. Although, hold that thought, because high availability of what? And just because you're using a platform that has components within it that provide high availability doesn't mean you get a high availability solution for free. So I was thinking about Mike's definition and then trying to think, well, what solutions out there match? And of course, we've got things like Azure Cloud Functions and Amazon Lambda, which sort of fall under the bucket of function as a service. But his definitions apply equally well to some of the cloud-based data stores, things like Google's Bigtable or DynamoDB, right? The sort of BaaS solutions, back-end as a service solutions. So serverless is definitely not just about functions. So with these back-end solutions, for example, what happens is I don't provision a certain size machine for my database to run on, but as I'm just using it, it will automatically adapt to how I use it, giving me more storage, more performance. At least that's the promise. Any of you here who've used SimpleDB on Amazon will know that the promise of back-ends as a service don't always deliver, especially in terms of performance. But there are other tools out there that I think match Mike's criteria. Okay, so I don't scale in terms of machines. I don't have to worry about services. It just handles things for me. You know what? Salesforce's Force.com platform fits Mike's definition, which is a bit of a scary thought for anybody that's worked with Force.com platform. It's a very powerful platform for people that want to effectively create more customized behavior around their use of Salesforce. There's a load of solutions on top of that. But really, that does actually fall into, I think, Mike's definition of serverless, even though I don't think it really follows the spirit of that platform. Do you know actually what else falls under that definition of serverless? CDNs, content delivery networks. If I'm delivering an application, which is a pure client-side JavaScript application, I could just use something like Fastly as a platform for deploying my application. I'm not scaling in terms of machines. I only pay for the amount I use. That is effectively, by its definition, a service platform. What about what I consider to be the gold standard of platforms as a service? Heroku. Is Heroku is Heroku serverless? Well, not according to Mike's definition, because we scale in terms of pods. And when you attach a data source, you talk about the size of a dynamo, how many dynamos you're running, for example. So, you know, this kind of Mike's attempt, I think, to come up, which I think is a very sensible attempt to try and come up with a specific definition of what serverless is, as a way of avoiding the term being overused, also gives us some interesting results when we apply it to the tools and techniques out there. So all of these terms, these acronyms, add to the confusion, right? We have so many as a services out there, it can be quite daunting to get our heads around them. We start off, of course, with the infrastructure as a service, which is where I started, the ability to run a line of code and provision some low-level type of computing primitive, you know, network, storage, compute. This is where Amazon absolutely shines. I think it's the one area where they do shine in terms of Amazon Web Services. We've then been building high-level abstractions, the emergence of the container as a fantastic artifact for distribution, scaling, and cost-effective, albeit not secure necessarily, isolation, has given rise to things like container as a service solutions, Kubernetes, Mesos, Docker Swarm, and so on and so forth. Higher-level abstractions, but we're still dealing in terms of often computing resources. We'll still say, I want this many pods. These pods should have this many CPUs, this amount of memory. And then, of course, we've had what has been for many years the Holy Grail and what we've been trying to move towards, the platform as a service, the completely opaque abstraction, the non-leaky abstraction, that allows me to just focus on my application and the platform magically deals with everything else for me. The problem has been, of course, is that these platforms have struggled a lot to achieve those outcomes. Where they've tried to abstract too much away from you, they end up being tuned for the common case and not necessarily fit your use case well enough. Or they require you to sort of really configure them for your application to work. What we've seen with serverless is really that this PaaS space has had other sort of sub-components broken out from it that we now talk about. Function as a service and back-end as a service are now components that give you a serverless platform as a service type solution. A serverless platform, I think, in my view, is by definition a platform as a service, something that allows you to focus on the application. But it's not as clear-cut as that. You look at the tools that are sitting in the CAS space, and they are increasingly adding higher and higher level abstractions. Kubernetes, for example, is adding more and more abstractions on top. I don't think it'll be very long until you've got good portable serverless frameworks that will just run on any Kubernetes cluster, for example. Another example would be something like Mesos's DSOS, their data center operating system, that allows you to treat the CPU, so the compute, storage and memory across your cluster just as a transparent pool. Solutions built on top of the data center operating system arguably are serverless solutions. And then it gets much more confusing, and you start talking about it. I find myself talking about this stuff at dinner parties, and you end up making a complete, ass of yourself. But people are starting to get it, and I think we're getting closer to these distinctions, but we keep talking in terms of technology. And I saw this nice tweet from Kelsey, King of Kubernetes Hightower, who has just worked out what serverless is. I'm being a bit unkind, right? But this is the heart of what we're trying to aim for. But I guess, channeling Adrian Collier, who I know earlier on was going back to his old scientific papers and taking out the word modules and putting the word microservices in instead, we could look at this tweet and take out the word serverless and put PaaS in there, right? A serverless is just a different name for a platform as a service, albeit maybe a bit more of a prescriptive abstraction that we're talking about. This is the goal, right? But come all the way back to that definition from 2012. After I've waded through all of the papers and things out there, still a definition I like the most in terms of what serverless is. Doesn't mean servers are no longer involved, it just means that we, as poor, humble developers, don't have to worry too much about what's happening underneath the hood. So, in a way, I come back to this term. How many people have heard this term before? Undifferentiated heavy lifting. It gets talked about a bit in Amazon circles. Like the first time the phrase was used was an internal Amazon white paper. And teams were being created to self-manage their own infrastructure. And so the idea was the teams would own the whole life cycle of their infrastructure and the applications. And they found that they were spending an inordinate amount of their time with just sort of work that wasn't differentiating what they're doing from what anyone else was doing. Provisioning machines, racking them up, and cabling them. And out of that, Amazon created Amazon Web Services effectively to abstract out all of these sorts of types of undifferentiated heavy lifting. But I think it was, and I think Amazon's strong suit remains, the ability to abstract this out for lower level type resources. They still haven't actually got this right for a platform. I still don't think Lambda is a fantastic implementation of the idea. But what we're starting to see is that other people creating these platforms that remove the undifferentiated heavy lifting for our whole application stacks. But puzzles remain. I have especially trouble with thinking about how we think of resiliency. Well, why do we care about resiliency, Sam? These platforms are highly available. Haven't you heard about WebScale? Haven't you heard about Amazon Web Services and lots of machines and Netflix? Netflix use it, so if I use it, I will also be Netflix. Or some other similarly tortured logic like that. Now, many years ago, I worked for a German investment bank. That German investment bank no longer exists. It wasn't entirely my fault, although I was partly to blame. We were pricing things called credit derivatives, and a subset of what we were pricing, actually within the derivative market, was a thing called the collateralized debt obligation. I won't explain what they are, but if any of you have read the book or seen the film The Big Short, you will understand that I played a small but important part in the global financial crisis. Who knew IT could turn so bad so quickly? Now, the solution we were deployed we were basically doing pricing of these trades that people were putting, and we're doing it during the day. The idea was that if a trader wanted to price up a derivative, they could get quick feedback that would tell them, is this a good idea or not? And the faster they could get that information back, this would theoretically give them an edge in the market and would help them manage their positions effectively. And so we created sort of a real-time pricing engine for this stuff, and we knew it needed to be scalable, and so we picked some technology called data synapse, which is a good old-fashioned pricing grid. This is about 2007, and so all the conversations really were about things like Java spaces and sort of pricing grid engines for scaling grids. No one was talking about Hadoop and all that stuff yet. MapReduce hadn't made its way outside of academic circles now of Google at this point. So we had this flexible grid of pricing engines, and we were pulling in all kinds of resources from outside. So we were pulling in information on different risk profiles and market data from external services, and we were sort of flushing out a lot of our pricing data to a database in the back end. Little side note, the reason we picked data synapse is because data synapse allows you to run Excel spreadsheets in a grid. which sounds like a really stupid idea until you realize at this point in banking, a lot of the traders were running their own, they were actually looking and analyzing their positions on their local machines, running Excel spreadsheets that they would then tinker with. So they wanted to make a trade so they could make some money. They didn't like the answer they got. They just changed what the Excel spreadsheet did until the right answer came out. Turns out that's not a good thing if you're trying to manage risk across now, not that the banks had any problems post-2007 with dealing with risk. So anyway, that was the reason we picked it. Now, we were actually curtailed early on. We only had about 25 machines to play with, and we really wanted to see what this grid could do. And we got chatting, actually, to a friend of ours in the sysadmin team, and he said, well, look, one of the nice things that data synapse lets you do is piggyback the sort of agents inside the grid on screensavers. And the idea was that you could use it in a corporate setting. You went for coffee. After a minute or so, your screensaver kicks in, and then it becomes available as a worker. And our jobs are often would execute quite quickly, and that actually was working out okay for us. But he said, but we've got a DR center. So all of the banks in the UK, and certainly the banks in London for the traders, they have to have a second office somewhere quite close to London that's far enough away that if there was an incident, they could still use it. So tube strike, terrorist incident, massive power outage, the traders could relocate to this other office and carry on their work. These other offices were often a little bit out of town. The computers were there, and they were on because they wanted to make sure everything was working, but they were not being used. And so our mate Phil goes, I'll just run your screensaver on all of these machines. Fantastic, this is awesome. So we found in these offices, and we went from about 25 pricing nodes to having over 200 in the space of 10 minutes. And it was so much fun. Just seeing the little slider creep up of the number of agents as the grid got bigger and bigger and bigger. And then we were pricing trades so fast. And then some bad things started to happen. Because every single thing that wasn't on our grid got completely and utterly overloaded by the agents running inside it. And this is the problem that you get when you've got a system which one component of which is massively, massively scalable, but not everything else is. You get nasty outages like this. And so I was remembering back to this when talking to someone about serverless, and I realized that we have all kinds of protections that we just put in place almost by default into our applications nowadays to try and protect ourselves from causing cascading outages or catastrophic outages like this. I mean, let's start with something simple like the humble database connection pool. Database connection pool works. I have a pool, has a certain number of workers. And if I want to talk to a database, I have to go and get a worker from that pool to allow me to carry out a database connection. So traffic comes in, and effectively, I have to request on the pool. There's a certain number of workers, and so inbound requests that need data access are going to block and wait until they have a worker available to them. So in this way, the database connection pool throttles the number of downstream calls that can go to a database. This is actually one of the ways in which we ensure that our databases are not overloaded by clients. Is by using connection pooling like this. This actually allows for load shedding as well. If the database is contended, those calls are taking a while, you limit the number of calls that can go downstream. After a certain period of time, the threads coming in will time out, and you effectively shed load. Load shedding is a vital part of resilience engineering. You don't want to keep just retrying stuff over and over again. That's not always a sensible thing to do. Retries imply you're buffering requests. If you have a downstream outage and you start buffering requests to retry, that buffer itself creates resource contention and can also cause a form of cascading failure. So a common technique is something bad's happening down here. It's better for me to throw away some requests and give this a chance to recover. And so actually database connection pools give us all of these things, and we just use them without thinking about how awesome they are. I would also say we almost never configure them correctly, but that's a separate conversation. So that's great in a traditional application, but the connection pool works because it manages calls across multiple requests. But if we think of a platform like Lambda or Azure Cloud Functions, they spin up functions when a call comes in. There's no place for my connection pool to live because each function is only ever going to make one call. As the load increases and I get more requests coming in, I spin up more functions. More functions equals more calls to my database. Where's my throttling function? I don't have one. So we open ourselves up to the same problem. It's actually interesting because I started poking around to understand how I could throttle functions. There is a soft account limit of 600 concurrent invocations of a Lambda request per account. but you can't configure that per function. It's just a wide account thing. The only ability you've got to throttle the number of calls you've got to a function is actually by doing that inside things like the API gateway and stuff like that. Still nowhere near as fine-tuned an instrument as a good set of connection pooling is. I'd also, of course, now at this point, the serverless people will come out and say, but Sam, you're clearly foolish because you have taken function as a service and applied it to the mere mortal database. What you need, son, is you need a back-end as a service. You need a massively scalable, highly available data store, because then as your load increases, these systems will just transparently handle the load for you. Again, experiences with things like SimpleDB to one side, this might be true, but then the implication is to build an application that is highly resilient. I can't actually mix and match pieces of software, some of which are serverless and some of which aren't. And so you're sort of telling me that if I want to really be able to handle this kind of load, I don't have the ability to throttle, and so I have to use other types of data store. It's interesting to note that most of these backends as a service are not transparent drop-in replacements for your normal relational databases. They're not. DynamoDB is functionally quite different to other types of storage. Bigtable especially is on the Google platform. And this is the reality, is most of us are not pure serverless stacks. For a brand new greenfield project, maybe you can be pure serverless, but most of us have software already. We would like to use the ideas behind serverless, use parts of the platforms from serverless to start maybe migrating in that direction, but we are going to be in a hybrid state for so many of us. And now we've got to worry about this thing scaling in a way that blows up everything else. Let's look at another commonly used resiliency pattern. I talk a bit about in the book. It's quite a fun pattern, the circuit breaker, right? Just like in your house, electricity flows across your house. When it looks like it's going to spike, your circuit breaker blows, it protects your appliances. And we use this to handle connections and downstream connections, and often we'll wrap them around any connection to another service or even something like a database. The way it works is really simple. Load comes in, and that funnels through the circuit breaker, and the circuit breaker is looking at the health of the downstream service. After a certain number of retries, or a certain number of timeouts, or a certain number of errors, it considers that the downstream service is unhealthy, and so it opens that circuit breaker. That allows us then to go from failing slow to fail fast, which reduces resource contention, allows us once again to shed load, and that gives that downstream service time to recover. You may also implement things like exponential backoff to avoid the thundering herd problem when that circuit breaker closes again. The issue is, for a circuit breaker to work as a throttling mechanism, it relies on state being maintained across multiple requests downstream. And we store that state in our clients. But again, if these are coming from functions, where's our throttling mechanism? Where is our understanding of the concept of the health of the downstream system? And of course, people say, well, the risk service can tell you about its health, but then networks are unreliable. So even if the risk service is healthy, it doesn't necessarily tell us whether or not we can talk to it. Which is why we do these things at the client side as well as at the server side. And these two problems do make me wonder if we start seeing more and more use of function as a service type solutions, especially in hybrid environments where we might be talking to other services downstream which don't have this transparent scalability, whether or not we are going to end up with some kind of throttling and load shedding middleware going on that's going to sit between these two things. There's some sort of communication fabric. I started thinking about how I could implement this. So I could have my function could go and check the state of a circuit breaker in, say, console or something like that, some sort of persistent set of shared state, get back a view on whether or not the downstream thing is healthy, and then before I make my call. But then I'm thinking, so now I'm doing an additional round trip every time I make a call downstream, and what if that round trip fails and my head exploded? So I talk to people that do a lot of work in serverless architectures, and I say, so what about this? And they go, yeah. But it's a problem. And I think, great, okay. Now, to be fair, I might be worrying about nothing. Not everybody needs a massively scalable platform, right? We come to conferences and we hear these lovely stories about Netflix and Spotify and, oh, great web scale, hyperscale, I need that too. And actually, many of us aren't in that situation. But I think it is important to actually analyze the promise of these serverless platforms as implicitly highly available, massively scalable, auto-scaling of load, You may or may not need that, but is it even going to give you what you need? Because your application as a whole is a collection of multiple things. Just because one or two parts of that have some highly available characteristics doesn't mean your system as a whole is going to inherit those characteristics. Security comes up a lot, and actually after some initial concerns, especially in the function as a service space, I'm much more relaxed about this. We know that under the hood somewhere that these functions are running on some kind of container engine. It may or may not be Docker, but we know that's what's happening. The call comes in, you fire something up, and that warm-up time is very, very short. So it's not a VM under the hood, right? It's got to be something else. It's going to be some kind of containered solution. Handles that request, and then it's torn down. But we're worried about containers from the point of view of security. Some of you may have seen Liz's talk earlier and learn a bit about that. And some of the things I start talking to people about come back actually to all the same worries that people had back in 2009. It's issues of multi-tenancy. The worry, by the way, because this is the other mantra we have. This is a saying we have around in my household. Friends don't let friends run untrusted code in containers. This is the thing. If you are going to run untrusted code on your own container engines, you don't. You actually run them in VMs because you need that increased isolation. Now, of course, if you're running on a cloud platform, you're running probably on the same container engine alongside other people's code, and anybody else's code that isn't yours is by definition probably untrusted because you don't know who they are, right? And so this general piece of advice that I apply and I stand with when you're running your own container solutions makes me worried. So what's this going to mean in the land of serverless? I'm actually less worried, actually, because if we think about the function as a service solutions, here's my function. And I'm worried that somebody else's function is going to take advantage of an underlying vulnerability in the container engine. There's a whole lot of different types of exploits where one container can reach out and see the content of another container, and they're going to access my process and my data. The reality, of course, with things like Lambda is that if your function isn't being called, it's not there. So from an exploit point of view, even if a malicious function managed to find the machine that your process is on, and managed to look at your process while it was running, it's kind of, there's time to thread the needle. And even then, functions should be small, although apparently, according to the keynote yesterday, it's not always the case, but they should be small. And so therefore, if I do get access to it, I'm actually accessing a much smaller piece of information. I actually think from a security point of view, these function-based platforms are actually a real boon to us. So I'm kind of less worried about that side of things. Because the other thing as well is, it's not like you're just saying to people, upload a Docker image. You're not. You're saying, upload some code, and they then run it in a sandbox that itself is on top of a container engine. And so the people with these fast platforms have the ability to further sandbox your process from another. That's why there's some of those limitations are on you in terms of what language you can run, for example. So Lambda does not support Go natively out of the box. The other one that does come up a lot, and again, much like the security aspects, the concerns about multi-tenancy, is a conversation about lock-in, right? Making a choice and being stuck with that choice. And this is a real concern. Now, the really interesting thing is that, once again, my advice really hasn't actually changed on this stuff whatsoever. But we do need to deal with the elephant in the room. Who's heard the phrase that cloud is utility? It's a complete and utter lie. It's not utility, is it? Right? Because utility implies a level of portability across providers, and pretty much transparent portability across providers. We think of utility, we think of water, electricity, mobile phone, fixed phone, internet provider, where my choice about what I want is down to a quality of service and a price point. I can go to Uswitch, for example, in the UK, and say, I want to pick a different electricity provider. I click a few buttons, and in a couple of days, my electricity is now coming from a different provider. I haven't had to change my appliances. The voltage in my house hasn't changed. I haven't had to have an electrician round to sort that out. That is utility. Cloud is not utility. There is always going to be a cost of moving from one to the other. And that is a legitimate concern. But I think the way we phrase it is often incorrect. We talk about lock-in, and I think instead we think about migration cost. Ultimately, when you pick one vendor over another, you're picking a solution that works well for you now, and you might later on have to migrate to another platform. So think instead about what the migration cost might be. And it's not actually the same for all types of services for all kinds of platforms. Let's think about the standard kind of services provided by an off-premise cloud provider. We start off with things like blob storage. This is where things like Amazon S3 sit, just straight up binary storage. Moving from provider to provider is actually pretty easy because ultimately the end service looks pretty much like the service you had. The only issue is literally the physical movement of data. And you've got Snowball for Amazon, so that's going to solve that problem for you, right? If you have to, you can send a 50-pound 7U rack mount machine with about 80 spindles on it and copy your data off, right? Blob storage is about as close as we get to a true utility piece of computing infrastructure. So that's not too hard. Compute, once you have the machine, it's the same, but the process of launching the machine is different. The way the price pointing works is different. This is a bit harder to move to. Load balancers. Again, load balancers are quite similar. You might configure them slightly differently, but the cost of migrating from, say, a load balancer on Amazon to a load balancer on Azure, it's not that hard. And semantically, here's a key thing. The end solution works very much like the original one. The semantics behavior of blob storage does vary a bit on Azure, but not massively. Where things get more interesting is when we start thinking about things like function as a service and backend as a service, especially the backend of the service type solutions. Most of the semantic behaviors of those backend as a service solutions are pretty unique to those platforms. You can't just go from Google Cloud Bigtable and just go and say, right now my application runs on Azure DynamoDB. You're going to have to rework your application, probably rewrite a lot of your persistence layers. Semantic behavior is very, very different. Therefore, your migration cost is going to be higher. So when you're thinking about, am I worried about being locked into one vendor, don't actually think just wholesale. It's not one equation. You need to look piece by piece at all the building blocks you're using from that vendor and understand what the cost might be down the line. Now, you might decide, if the cost is really high, that you might then invest in maybe something like an abstraction layer on top to make it easier to move. But then you're paying a cost now to potentially yield the benefits later on. I see lots of clients trying to build things like cloud brokerage platforms. I've managed to kill a couple of those in my time. I think they're an actual waste of time. You're spending a huge amount now to create an abstraction layer over different cloud providers in the hope that you can then migrate later on if you decide to, perhaps, maybe. That seems daft to me. Definitely paying money for now to give you a benefit you may or may not need. But do be aware of these things. As you move into these things, there's a cost going to be associated with migrating, and therefore you might be a bit more hesitant as you get deeper and deeper into any one vendor and any one stack. The problem, of course, around serverless stuff is often we're building solutions that are more interconnected. And so one way to mitigate lock-in is often to think of hybrid solutions. And I think from a corporate IT strategy, it makes sense to maybe spread your eggs around a little bit. We're going to do some stuff with Amazon, we're going to do some stuff with Microsoft, we're going to do some stuff with Google, we're going to do some stuff with DigitalOcean. And I think from an enterprise IT strategy, that can make perfect sense. It's a good way of spreading your bets, building competency across multiple platforms. But for specific solutions, I don't think it always makes sense, especially in the world of serverless. In the world of serverless, especially if you're using it to implement microservice architectures, the applications you're building are much more interconnected. And what does mixing vendors mean when you've got interconnected applications? I'll tell you what it means. It means latency. Right? So do you really want to have a backend as a service provided by Google and your functions running in Amazon Lambda when you've got like all the nice network hops going into and out of? And I think probably not. So I think for any one given interconnected solution, having that sit clean within inside one vendor probably does make sense. The other thing to remember, of course, is that you might be locked in, but actually maybe the place you're locked into is quite a nice place. People talk about the apple walled garden. I've been happily living in that walled garden for many, many years now. I'm sure there's stuff I'm missing out on, but it's really lovely inside that walled garden. We've got nice deck chairs, there's a lovely pool babbling away. It's impeccably designed, you know. Yes, I hear the neighbors have got some brand new funky stuff, like, fold-out deck chairs or whatever, but this is a nice place. So this is the other thing, when you embrace a platform and embrace it wholesale, you really get to take advantage of every type of aspect it is. Everything, lovely little nook and cranny you get to explore and you get to know, you get to build deep, deep competency in that, and maybe if you're big enough, you might actually get some, support from them. It might be a nice idea. So there's some things I'm clear on after my journey into serverless, and some things I'm still very much confused by. And part of my confusion comes because we've seemed to, with serverless, have devalued the term even faster than we've devalued previous terms. It took a while for us to completely devalue the definition of agile and overload it with lots of different terms and things like scaled agile for enterprise, for example, which is a great way of implementing agile without changing anything, which I find hilarious. And then we've got things like DevOps. People now talk to me about, I'm a DevOps. Oh, really? Oh, I'm a teapot. DevOps teams, that's not what it's about, but we've got them now. We have DevOps solutions. But it's just about people talking. DevOps solutions. Did you not hear me? I'm in the division of DevOps. Okay. And then microservices, of course, my own pet. This is what this means is shifts by the week and by the vendor you talk to. I mean, most important thing, of course, about this is that you keep buying my book. But serverless has managed that transition to meaningless even faster than any of these terms before. The one thing I'd like to remind you on is ignore the specific definition. The goal are platforms that make it easy for you to focus on the job you're doing. Just because the solution you're using doesn't talk about being serverless, who gives a crap? If it works for you, if it hides the detail from you, then don't worry overly about what it's called. Learn from those solutions. I think things like function as a service type platforms are incredibly empowering, for example. But just because it hasn't got a tag on it doesn't mean it's important. And just because it does match somebody's definition of serverless doesn't necessarily mean it should be the computing platform for you. Computers are not going away. I'm actually quite happy that we are now getting better at developing abstractions over those computers that make things easier to work with. The types of serverless offerings I'm seeing now are nothing more, nothing less than a much better developer-friendly abstraction over computers than what we've seen in the past. We kind of see the art of the possible. And I'm hoping all of those tools out there will continue to borrow from that world and create nicer, friendlier developer abstractions. You may not have it now, but I'm hoping that the majority of us in 10 years from now will have access to these kinds of platforms that allow us to focus on the problem at hand. Thank you very much for your time.
All right, thank you. I think we have time for maybe one question, so I'll let you pick, or you can just pick the one from the top, maybe.
It's got all the little ticks on it. I've got to do that one.
Yeah, right.
Okay, do I think that Amazon Lambda is enterprise ready? Depends on the enterprise. I know lots of people using it in production, but every organization has a different risk profile. And I haven't seen too many gotchas around it recently. It's been fairly out there mature for a while. I think the bigger issue is, are you able to use it in the right way? But I absolutely know people running production systems on it. But every organization's risk profile is different. One more?
Yeah, Jon Snow. We got to go with Jon Snow.
Yeah, thank you. Is a REST API combining DynamoDB Gateway and Lambda a stupid idea? Not necessarily, no. I mean, in that world, you effectively are buying totally into Amazon's, sort of automatically scaling components. You're probably unlikely going to suffer from that bursting I showed you with those hybrid applications. It may be absolutely fine for you. As always, caveat emptor, please test it, but not a stupid idea. Of course, that is you're fully into their world, which means these components should work very, very well together.
All right, thank you so much. Before you go, we would like to offer you a little token of appreciation from craft organizers. One more round of applause for Sam. Thank you again.
Thank you, Jose.